Now say here in this numerical, what is the de Broglie wavelength of a nitrogen molecule in air at 300 Kelvin? Assume that the molecule is moving with this root mean square speed of molecules at this temperature. And now atomic mass of the nitrogen is 14 point this. This is the nitrogen atom is atomic mass is this much. If you take nitrogen molecule, so mass of N2 is equal to 14.0076 into 2 is equal to, that is 28.152 U. This is the mass of nitrogen molecule. Now we have to calculate wavelength. So wavelength we can write lambda is equal to h upon mv, that is h upon under root of 2 me, that is kinetic energy. Kinetic energy of the gas, this nitrogen, can be written 3 by 2 kT, that is a Boltzmann constant. So it will become lambda is equal to h upon, here you will place 3 by 2 kT, 2 will get cancelled, under root of thrice of me, and now here that is mkt, this one. You can put all these values over here like this in place of k, t and m. Everything is given to us. T is given to 300 Kelvin, and now so just I will put over here, so lambda is equal to 6.63 into 10 raised to power minus 34 divided by under root of 3, that is a 1 atomic mass unit m. M is given to us, that is 1 point, no, that is already we have calculated, 28.152 into, that you have to change into the, that was AMU, that we have to change into kg. So that will become 1.66 into 10 raised to power minus 27 into Boltzmann constant, this is k, and k is coming 1.38 into 10 raised to power minus 23 into 300. So everything is under this square root. So when we solve all these, we will be getting lambda is equal to 0.275 into 10 raised to power minus 27 meter. So this is the de Broglie wavelength of the nitrogen molecule.